Hello! We're gonna do the second page of our notes tonight. The second part is basically what we've done in the tutorial. So you have the notes, and we'll do some example problems. And the first part, let's talk about temperature for a second. Temperature is an interesting unit. It's something that's innately felt by us. We feel temperature. We can quantify a temperature based on how we feel, whether it's hot or cold or freezing, right? And yet it's not a measure of anything actually measurable. So it's the amount of kinetic energy, so the movement of the molecules, and the molecules slamming into each other as they're moving creates heat. And so we can measure heat energy directly. Temperature is a more sort of indirect measurement. It's speed, but it's not speed in meters per second kind of speed of moving particles, but it is a measure of kinetic energy, so the energy of movement. Because it's so indirect, there are lots of different ways to make a scale for it. And the one we're most familiar with in the United States, of course, is Fahrenheit. And that was proposed by this guy Daniel Fahrenheit in 1724, you see there, using these endpoints, 0, 32, and 96 degrees temperature. And then shortly thereafter, in 1742, Celsius was proposed, again, named after the person who proposed it, Anders Celsius. And it's a little more straightforward. They used 0 for the, actually these are reversed here. So 0 is the freezing / melting point of water. And 100 degrees is the melting / boiling. No, yeah, the boiling point of water, of ice. What? The boiling, so yeah, switch those. Kelvin is a more absolute scale because it goes all the way to 0. So 0 degrees Celsius is not actually 0. 0 degrees Fahrenheit, obviously not 0. 0 degrees Kelvin is absolute 0. And it's the temperature at which, I'm sorry, I'm getting my pen here. Absolute 0 is the temperature, the amount in which atoms would stop moving. That would be absolute 0. And we actually have not been able to create that in a laboratory setting, and it doesn't actually exist even in outer space, to the best of my knowledge anyway. Even way out in outer space, there's some solar radiation, some heat energy that gives molecules some small amount of movement. So absolute 0 when molecules stop moving. It's related to Celsius by not a direct, but this equation here, where you just add 273. We don't have to worry about the 0.15 for this class. We'll just remember that Kelvin equals Celsius plus 273 degrees. We also have here next to it the conversion for Celsius to Fahrenheit, which is a lot more complicated. So we have a couple of examples. The first one over here on the right is dry ice sublimes, and hopefully you recall that sublimation is when you go straight from a solid to a gas and you pass the liquid phase. So at negative 78 degrees Celsius, that's when it turns to a gas. And we want to know then what is that temperature in Fahrenheit, and then what is it in Kelvin. So I'm going to rearrange the equation a little bit to solve for Fahrenheit, and it's actually not that hard. So we're going to do degrees Fahrenheit equals, we're going to flip the Celsius Fahrenheit conversion. So 9 degrees Fahrenheit over 5 degrees Celsius, okay? And then we're going to take the negative 78 degrees Celsius, and we're going to add 32. And that's going to give us our Fahrenheit conversion. So the equation over here was how to calculate for Celsius. If you want to count for Fahrenheit, you're going to flip the 9/5, and instead of subtracting, you're going to add 32. Okay, so when I do that math, I get negative, and I'm going to have to zoom in here a little bit because I'm running out of space. Oops, zoom in. Let me, where'd my eraser go? It's not going to let me erase anymore, so let me just write the answer up here. Negative 828, 8, not 6. 828 Fahrenheit. Okay. So that's the relationship between Celsius and Fahrenheit. Kelvin, much more straightforward. Kelvin is going to equal negative 78 Fahrenheit. I'm sorry, negative 78 degrees Celsius plus 273. It's going to equal 195 Kelvin. And the other interesting thing is that we don't use a little circle for the degrees sign. So we do use it for Fahrenheit and we use it for Celsius, but they don't use it for Kelvin. It's just 195 Kelvin, period. That's it. Okay, so there's our two answers there. Okay. The last example, really similar. Diamond can be formed from carbon materials at a temperature of 1,652 degrees Fahrenheit. What is this temperature in degrees Celsius and Kelvin? So degrees Celsius is going to equal 5/9 times 1652 degrees Fahrenheit minus 32. And plugging that into the calculator gives me 900 degrees Celsius. That's not 906, that's 900. Okay, and then to solve for Kelvin, I'm going to take the 900 degrees Celsius, and I'm going to add 273. Oops, 3, not 9. 273. And I'm going to get, is that right? 900 plus 273 equals 1173 Kelvin. Okay? All right. So that's temperature. Let's look at the notes for converting between units. This is what you did in the tutorial, and except for the last one, they let you just drag the conversion factors into their little boxes. So we're going to have to be able to do that on our own. So it has some steps here to show you identifying, this is the important step, identify what the unit that they give you and the unit you're trying to go to. And then you identify what conversion factors you need, so what things are going to get you from the given to the desired quantity. And then you're going to create a map. And then you're going, so you can send this part right here could be kind of a thought process, or it could be where you're already writing it out here in your equation. You plug in your conversion factors and then calculate, okay? You do not need to memorize regular standard conversions. I will give you those. The only thing you need to memorize are metric conversions, and that's why we came up with the mnemonic of kids have dropped over dead converting metrics, so that we can convert from one metric unit to another, because those are just blocks of 10, right? Okay, so let's do some examples over here. I'm going to move this over, and I might need to go back and forth to get to my conversion factors, but this is like the one you did for homework. So you have 15 years, and we're going to set up a big thing here, and the thing that's closest to yours I know is that 1 year is 365 days, Okay, and then, let's see, years is going to cancel out. And what's another one? I'm trying to get smaller than days, so one day is 24 hours. And then 1 hour is 3. I'm going to just quick, 60 times 60 is 3,600. Okay, 3,600 seconds. So days cancels out, hours cancels out. The only thing I have left is seconds. So that is the correct formula. So then I just plug that in the calculator, and I get 15 times 365 times 24 times 3,600 is something crazy. 473040000 seconds. Okay. There's that. All right. The next example, 1.8 meters is how many yards? So let's go back over here and look at what we have for conversion factors. What's my relationship in yards? I have yards to feet. I have feet to inches. None of those meters. Oh, here I have meters to feet. So I can go yards to feet and feet to meters. Okay, so let's move back here. Set up my problem, 1.8 meters. And I'm going to go, what was it? Meters to, feet, and feet to yards. Okay, meters to feet and feet to yards. Okay? And then I can plug in the data. Meters and feet, 3.281 feet in 1 meter. 3.281 feet in 1 meter. And there are 3 feet in 1 yard, right? 3 feet in 1 yard. So then I just do that. So let's double check that my units cancel out. Meters cancels out. Feet cancels out. I have yards left. So my answer is 8 times 3,281 divided by 3. And I get 8,749.3 repeating yards. Okay. 4.9 quarts equals how many cubic centimeters? So what do I have over here? Quarts. Interesting. Okay, this is going to be fun. Quarts. I can get, the only thing I see here with quarts is this one, gallons, quarts, and pints. Oh, here we go. Okay, so quarts to gallons, gallons to liters. And then I'm going to add down here because I know that I'm going to go liters is 1,000 milliliters, which is 1,000 cubic centimeters. I think that's right. 1 milliliter is 1 cubic centimeter, if you remember that conversion. So now we have our map set up. So I'm going to go back over here, see if I can remember it now. So I have 4.9 quarts, write down the thing that they give me. Okay, and now let's look at my relationships again. Quarts, 4 quarts in 1 gallon. 4 quarts in 1 gallon. And 1 gallon is 3.785, right here, 3.785. Oops, there's our bell. Hang on. 1 gallon, 3.785 liters. 1 gallon, 3.785 liters. And then 1 liter is the same as 1,000 cubic centimeters. Okay, and that's from, I basically shortened this conversion here. 1 liter is the same as 1,000 milliliters is the same as 1,000 cubic centimeters. Okay, so double check that my units cancel out. Remember, we're forming habits, so we want to Always check. And then I'm going to take 49, and remember in PEMDAS, it doesn't matter if I can divide, I can take this and divide by this and then multiply by this, or I can multiply across and divide by 4, it doesn't matter. So I'm going to take 49 divided by 4 times 3.785 times 1,000, and I get 46366.25 cubic centimeters. Okay, and not all of those units mean something. Essentially, it's going to be just 46,000 cubic centimeters, is, if I think about significant digits. Okay. Next example is about area. So we're going to work with squared or cubed units. This is a squared units problem. If I have a sheet of paper, it's asking me the area of a sheet of paper that is 8.5 by 11 inches in square centimeters. So the first thing I have to do is find out the area of the sheet of paper, which means I have to multiply 8.5 inches times 11 inches. So I'm going to do that here just really quick. 8.5 inches times 11 inches. And that's going to give me, typing away here, 93.5. So equals 93.5 square inches. Okay, that's actually the area of that sheet of paper. So I'm going to take 93.5 square inches. Okay. And then, if you remember from the tutorial, I need the relationship between inches and centimeters, which is right here. They're 2.54 centimeters in 1 inch, so that's going to be my relationship. So coming back over here, I just need to do this twice. 1 inch is 2.54 centimeters, and 1 inch, 1 inch is 2.54 centimeters, okay? And then when I do my canceling units, I have 2 inches here, and so 2 inches cancel out down here, and I end up with centimeters twice. And that's going to be my square centimeters. So then I'm just going to take 93.5 times 2.54 times 2.54. And I get basically 603 square centimeters. All right. So when you have double units like this, you're just going to do the same conversion twice. There would be a shortcut way to do this, which you could do, which would be to square 2.54 and square the inches and square the centimeters. Okay, last problem is when you have double units. So you have the speed limit under Jimmy Carter was 55 miles per hour. 55 miles per hour, okay? And it's asking me the speed in meters per second. So this is not as hard as it looks. You're just going to convert the units separately. So I need to convert miles into meters. I want my answer in meters. And then separately, I'm going to convert hours into seconds. So let's go back to our list of conversion factors and see if we have a miles and meters conversion. Okay, not quite, but close. I have miles and kilometers. And then I can convert from kilometers to meters. So I'll show you how to do that. Oops, I want to go back to this. So wait, what is the relationship? 1.609 kilometers in 1 mile. So 1 mile is 1.609 kilometers. Okay, and I do that so that I can cancel out miles. And then I need to convert kilometers to meters. And I'm going to do this in blue down here. I'm going to remember my KHDODCM. Kids have dropped over dead converting metrics. Okay, and right now I have kilometers, and I want to know what that is in meters. And meters has no prefix, it's one letter, so it's the ones placed. And so I need to go 1, 2, 3, there's 10 100,000. So let's think of it that way, 10 100,000. So there are 1,000 meters in 1 kilometer. So remember that as I go this way, there are more of them. So there are more meters than kilometers because kilometers are smaller and meters are bigger, so there are more of them. So the relationship is 10 100,000 times different, and there are 1,000 meters in 1 kilometer. So I can now write that in. 1 kilometer is 1,000 meters, and then my kilometers cancels out, and I'm left with meters, which is what I want in my answer. And then I have one more conversion, and that's from hours to seconds. And does it tell me some relationship? Do I need to know a relationship, or do I know? I know that there are 60 minutes in an hour, and there are 60 seconds in a minute. And so I'm going to just, since I have very little space left, I'm going to do the conversion that there are 3,600 seconds in an hour, which is 60 times 60. Because hours is on the bottom of my units here, my miles per hour unit, in order to cancel it out, I need to put it on top. So 1 hour, I'm putting 1 hour on top, and that's so that the hours cancel. And 1 hour is the same as 3,600 seconds, okay? And seconds doesn't have any, there's nowhere else there, so it's going to be left over. So the two things I'm left with are meters and seconds. Meters per second, which is what I want my answer in here. So all I have left to do is the math, and I'm taking 55 times 1609 times 1,000 divided by 3,600. And I get, the answer is, this is a big number. If I did the math right, 24582, I'm just rounding to the ones place, meters per second. All right? So that's how those multi-step conversions work if you have 2 units you're trying to convert. Okay, and that's it for today. Tomorrow we'll practice.